Hello doctor, we hope that you are doing good and safe. My name is Hamza Lahlali. My teammate and I agreed that I will be the one representing them, so I will speak on their behalf. Our project is about the noise detector, and the main purpose of this project is to control the noise in specific areas like libraries, offices, and also hospitals, in order to respect the rules and the regulations. It aims then to control the noise pollution, decrease it, and improve our infrastructures, standing then against 21st century challenges. So let's see the EDP tools that we used.
During all this semester, we faced some issues regarding the team. In fact, each team member has different ideas and perspective about the design of our project. We tried then to navigate, accept each role, and work properly, performing and making good decisions. We consider ourselves now as a high-performance team, with all the respect, efforts, and time shared together. During this semester, we tried to organize our work regarding the project using different project management tools as the work breakdown structure or the CPM per chart to know the lowest duration for the accomplishment of the project. We allocated then each week of the semester using the Gantt chart to stay up to date with our design. We defined many requirements for our noise detector using the prioritized table and assigning a value to each one of them by importance rate. As you can see, we wanted our product to be safe, efficient, with low production cost. So we made an objective tree to order all this up. We defined after that our wishes, constraints, and demands concerning the requirements that we will discuss it under the specifications. Moreover, the use of the steeper analysis helped us to discover more about the societal, technical, environmental, ethical, political, legal, and economic external factors and constraints. After the requirement, we should now quantify them into specifications, and the main ones are as you can see in the table. To know all of these, we use the QFD tool, differentiation and showing the relation between the customer demands and the quality, product, and manufacturing processes. However, and in order to determine our customer satisfactions, using, in other words, the Kano model, it is necessary to compare specification and initial requirements, quantitatively, allowing us then to calculate the relative and absolute importance. For that, we use the house of quality, and the main purpose is to see how we can achieve those requirements. After all of these, we had to choose the components that will be used for our design. For that, we used the reverse engineering of a product called Deco Plus Noise Detector. The different steps of the reverse engineering helped us to see how it was made, from which materials, and why. We then choose many components for different designs, and we organized them in a morphological chart as you can see. We generated then many concepts that could be evaluated by both the decision and Pew matrices. And that was the topic of our workshop, so we did not have any problem here. We could then select the design with the highest score. But we did more than that, by combining the strengths and weaknesses of each design and using our engineering sense to come up with the most suitable design, feature our requirements and customer specifications.
But before showing the mockup, we should not skip one of the most important parts of the EDP, which is the ideation, or the idea generation analysis. This will help us to see what's wrong with our product. For example, in our case, we need a battery. In other words, we need electrical energy to use noise detector. So here, we need to modify it. We need to see alternatives. We need to adapt it to the reverse product that I said before, and we need to improve it. For example, why can't we use the solar energy? And here, we choose the best alternatives that are feasible and safe. Now, we will see the mockup.
So as you can see, this is the mockup. So normally, the microphone here in the big sound will detect the incoming sound. It will then vibrate and transforms the sound through its membrane into electrical signals. When noise level reaches the threshold value, the red LED here and the small buzzer here will automatically get triggered by the Arduino. So now I will show you how all the components are connected. So first, we used two main components, the Arduino Uno here and the big sound here, or the sound sensor module. We use these two components because they are inexpensive and they are easy to use for beginners and then for our customers. We used 9 different wires of different colors. The red represents the positive terminals and the black one represents the negative terminals. In addition to that, we connected the ground lever here of the Arduino to the horizontal line here of the breadboard in order to have a negative value or a negative sign in all this line. Same thing for the 5-volt pin. We connected the 5-volt pin of the Arduino to the other horizontal line here in order to have a positive sign in all this line here, horizontal line, because we know that this horizontal line is connected, this other horizontal line is connected, and each vertical line here is connected. So after that, we just power supplied the big sound by then connecting the positive pin and the ground pin to the positive and negative line respectively. So this indeed match our requirements and the requirements of our customers, which are a product easy to use, easy to operate, and a maintenance cost not expensive at all. So after that, we connected the digital pin of the big sound to a specific digital pin here in the Arduino, and same thing for the analog pin of the big sound to a specific analog pin here in the Arduino. So same principle for the LED, the buzzer, and same thing for the resistor that protects the LED. So the customer can modify the digital or the analog pin if he wants. He just needs to modify the C++ programming of the microcontroller that you can see now on the screen. And so it is very easy to use and very easy to operate. So now all the components are connected. The customer needs just to power the Arduino by using a battery between 7 and 12 volts in this entry that you can see here. He can use this small battery of 9 volts, or he can use a USB cable type B in this entry here. And the USB cable is like this one. He can then power it by a computer or by a power bank. It depends on his preferences. So now I will connect the Arduino to my laptop and we will see. So after we connected the Arduino to the laptop, you can see that it is powered by, you can see from this slide that it is powered. So now we will test it by using a noisy crowd sound that we found on YouTube, and that we will put the link in the description of this video. And this sound is like the one that we can find in restaurants, for example. So here it is, and normally when I will turn on the video or in the noise, the LED and the buzzer will automatically turn on. So let's see this. Let's redo it another time. Let's stop it to see what happens. It stopped. So as you can see, it is working. The customer can easily repair if there is some issues, and there are no dangerous like components for our customers. It is safe for the user, and the design can detect efficiently and automatically the incoming sound. It is, in addition to that, easy to assemble and deassemble, and this will then accomplish the main goals of our project, and it can then have a good position in the market. So this is the concept of this design, the noise detector. The design cost us 400 dirhams. The Arduino was the highest cost with 150 dirhams. This is why it has the highest percentage. We don't hope to make a profit of 100 dirhams per unit, selling it at 500 dirhams, like or less than our competitors. We can conclude from all of these and from the use of competitive benchmarking, as you can see in the screen, that we have a good position in the market, as I said before.
Before ending this video, I invite the professor to see the poster that we made for this design. The link is in the description of this video. So in order to make our project more clear than that. So this is the end of this video. Thank you, Professor, for your time. Thank you for your help. It was a hard semester, but a great one. So we hope that you are proud of what we did. Thank you, sir, and see you soon. Goodbye.